Hi, welcome to CreepGame Assignment 2.05. The requirements for this assignment are to write an offline tool that can read in FBX files and write them out in our own custom binary format. The purpose of this is so that we don't have to do any processing in our game. It's all done offline, and therefore it'll speed up our load times. And the second requirement is to rewrite our Pong game to use the data that our offline tool produces. Let's take a look. So here's our solution, and you can see now that we have this FBX importer tool. But let's start the game. Press F5, load up a paddle, and start the game. Okay, you can see now that our ball and our paddles are made with this cube shape. And if I start up our mini Pong balls, a little hard on the eyes, but you can see that they all use the same. I paused it, so you can see they all use the same cube shape too. Now the FBX model for this cube was created by the Cube Creator example in the Autodesk FBX SDK. The model was read in by the new FBX importer tool and written out to a custom binary file. The custom binary file was then read into the Pong game and used for the ball, paddle, and mini balls. The FBX model also included the crate texture, and that got written out to the binary file and read in by the game with the rest of the crate data. Now, by simply modifying a configuration file, we can use other FBX models in place of the crate. Let's give that a try. Let's first get out of the game, and then we'll bring up the configuration file. Now, this configuration file is read by both the game and the FBX importer tool. So this line here is what the importer tool looks for, this word here, to find the name of the FBX file to read in, and here it finds the name of the custom binary file to write out, and this is the line that the game looks for, and you'll notice it's the same name. It's the name of the file that it wants to read in for the cube. So what we're going to do now, though, is instead of having it read the game read in this cube data, we're going to have it read in this humanoid data that we've already prepared. So I'm going to uncomment this line out and comment this line and then save it, and then I'm going to run the game again. F5. I'll select the paddle and start it up, and you see that the ball and the paddles are now a humanoid shape, and the humanoid looks kind of flat, like it's a flat model, but it's not. It actually has about 1600 verts, but it looks flat because there was no texture data in the file. Now, I also added a large version of the humanoid to the water world, so let me turn on the water world and you'll be able to see that. Okay, once this wall moves away. Okay, so there you can see in the background there's a very large copy of the humanoid. And now I also have a monster FBX file. So let's give that a shot. Let's see how that looks. Get out of this. We'll go back to our config file. We'll comment out the humanoid line again, and we'll uncomment this monster line here. Save the file. Start the game up. Choose our paddle size and get that going. Okay, and now you see that the ball and the paddles are represented by this this monster model. Now this model is a model created by an artist in our class, and it has almost 6,000 verts. And I suppose if I hit O, I would get a whole bunch of little monsters too. Yeah, you can't really tell very well, but I'll pause it. There's a whole bunch of little models in there, each of them having 6,500 verts, but you'll notice that the vert count isn't really that high because they're all sharing the geometry, which is what we had to do in a previous assignment. Okay, so let's take a look at some code. So here's our FBX importer tool, and here's the main file here. And you'll notice that our importer has only two methods. It basically says import from FBX and export to binary. Nice and simple, right? And here's our main code, and it basically creates one of those importers, and says if you can successfully import from the import file name, then I want you to export it to the export file name. Pretty simple. Now let's take a look at those functions. Import from FBX. Now this file basically uses a lot of the Autodesk FBX SDK, and it puts it all into a structure that allows easy access for me. So that file is not quite so important, but here's the export to binary where we actually get to see the custom file format that we use. So we basically open the file that we're going to write it all out to. Then we don't know how many bytes total it is yet because we haven't really walked through the data, but we're going to write it out just to allocate some space for it. So we seek to the beginning of the file, we write out the total bytes, which is just 0 for right now. Then we use some helper methods which write out the number of verts as an integer, the number of indices as an integer. This is all being written out to the file, and the length of the string name of the texture file, and then it writes out that string itself, and then it writes out all the verts, and it writes out all the indices. And now that we've walked through it all, we know how how much data we wrote out. So we seek back to the beginning, and now we write out the actual value of the total bytes. And the reason we put this right up front is so that when the game reads it in, it can know how big a structure to allocate because it now knows how big the data is that follows. And then we save the file. So that's basically the important parts of what the tool does. There's a lot of nitty-gritty that goes on talking to the Autodesk API, but that's not really that important for here. So now let's go to the game, and you'll see here when we're initializing the geometry, we read in the FBX binary file, the custom file format, and right here is where we actually add the geometry for that particular crate. We add it to the render engine. And if we look at here's the file where we're actually reading it in. So let's go to that actual function. Here's to read the binary file, and you see the file name was passed in. So we open the file here. We see that it's okay. Now we call a helper function which says get the length, which we wrote out in the first few bytes. So it now has an idea of how much data is following. So it allocates some memory here so that we can read that data into a chunk of memory, fills it up with zeros, and then it reads all the data. So there's really one read that occurs in here to get the length, and one read that reads in all the data. So we get that entire file in just 2 reads. One of them, one quick, and the other probably pretty quick. And then here we basically say that this data is really going to be one of these FBX input data structures, and here we got a pointer to it. And so now we've read the entire thing, and let's take a look at that structure that we've basically read it into. And you'll see here is the structure, and basically this is just like the data that we wrote out. It's the number of verts, the number of indices, the size of the name of the texture, and then there's the variable data here, and the variable data starts out with the texture name right at the top. You can see there's the data. That data, it represents the entire rest of the memory chunk, the variable part of it. And then you'll see the verts. Basically the way we get the verts is we say, okay, look at the data, offset yourself past the name itself, and that will be all the vertex data, and here's the kind of stuff it will be. It'll be a whole bunch of these vertex structures. So basically an array of those vertex structures. And then when you want the indices, basically it's find the data, go past the name, go past all the verts, and that'll be the indice data. So what we've done is read the entire file into a structure that can just grab any part of it that it needs without any processing. Just simply reading it into memory. And the value here is that we basically used a common file format for models, namely the FBX format, and we did a bunch of processing on it and put it into a format that our game that is specific to our game. It can just easily be consumed, and we did all the processing offline. This game needs no processing, and this helps speed up our game load times, which is a very good thing. Okay, so that's my overview for my CreepGame Assignment 2.05. Thanks for watching, and goodbye.